So the next step in the process is to try to figure out if there's a statistically significant difference. Let's see what we're doing here. Okay. So we'd want to figure out if there is actually a statistically significant difference here, and we'd actually have to do a statistic. Does anybody know what the statistic, now this is not a statistics class, does anybody know what statistic we would actually do where we have one independent variable and two levels and one DV? Does anybody know what statistic we'd actually run on this? It would indeed be a t-test. Now, there are two types of t-tests you could potentially do. There's what's called a paired t-test and an independent sample t-test. Does anybody know which type we would run on this situation? Would it be a paired or would it be an independent sample? And if you're not sure and you want to guess, you can guess.
Would it be the independent?
Independent sample, why would you say that?
Because it's testing one variable.
Not just one variable, but you're close. Go ahead. Let me see if Kate can add to this.
I would also say the independent sample because there's nothing, usually with the paired, they're already paired together, but they weren't paired.
So in an independent sample t-test, important for your notes, in an independent sample t-test, everybody is only tested once. And in this situation, was everybody only tested once? Yeah, how did I manage that? I decided last night that you'd kind of switch off, that one of you would be the experimenter in one situation and the other one would be the experimenter in the other situation. And so what we're going to do is an independent sample t-test and to see if we have some significant results here. So, if you do have a computer about you, see if I have this here. The program I'm going to go to, and if you want to write this down, and I've got it. Am I recording here? Yeah, it looks like I'm still recording here. It's called www.graphpad.com. www.graphpad.com. And look what it might do for us. Does it look like it might be useful? Yeah, it does. We're going to choose an unpaired t-test. That's also called an independent sample t-test. Group 1 will be the numbers from maybe list A. So I've got them up here, so I'm just going to put in, and if you're in the online class, you can write these down. I've got a 6. I've got a 10. I've got a 6. I've got a 9.78. What should I do with that?
Round up to 10.
Round up to 10. I've got a 6. And I've got a 7. So 6 pairs there. And then I go to group 2. Or so I hope. What is group 2? So list group 1 is what level?
High frequency.
High frequency words. So if you want to write that for your notes, it's high frequency words. Group 2 will be the low frequency words. So we've got a 12. We've got a 20. We've got a 13. We've got a 15. We've got a 12. And we have a 14. So that's what we actually have in this situation. Now, does it matter? When we were running it, was there one person who maybe shouldn't have been running as a subject in this experiment? Who should that have been?
You.
Me. Did I know all the words?
Yes.
Should that really necessarily matter? It could, but it probably didn't. My number was kind of very close to the group mean there. I think, I'm not sure, what was my number here?
It was 12.
It was 12, so kind of on the low end, but still, so you could potentially take me out of the equation. But the word frequency effect, it doesn't really matter if you know the words. As I was reading them, was I just kind of quickly going through them, or? No, obviously I knew the words because I just made them last night. It would have been nice if the 12th person was actually here, but we did what we could. So now we're going to actually run an independent sample t-test. And if you go to this yourself, this is not a statistics class, so you will not be asked to do statistics on your own. But we've got unpaired t-test, and guess what we do? How about calculate now? So we do that, and when we click it on calculate now, we've got the mean for group 1. The average time to read the first list was 7.5. For group 2, it was 14.3. Is that good news for me as the experimenter with my hypothesis? It took the group almost what? Twice as long. Was I hypothesizing that? Yeah, I was. So, a few other things that would be important. So, let's go to this top line here. P-value, it says 0.0009. Good news or bad news there? 0.0009.
It's good news because it's significant.
It is indeed significant. Anything that's less than what is considered significant?
0.05.
If the p-value is less than 0.05, this result is considered statistically significant. So please write in your notes, p equals 0.0009 for your notes here, and that's kind of the way of it. So that's a good thing. Let's see what else we've got here. We've got a t-score. This will be important a little bit later. If you want to write the t-score down, t equals 4.6. You can write down 4.65 if you want. So the t-score is 4.65. Can you see it up there? Is it showing up? Yep. That's good. Degrees of freedom. Anybody know how it comes up with the degrees of freedom of 10?
It takes the number of participants minus the groups.
So how many people did we have in the first group?
6.
6. So how many degrees of freedom there? 5. How many people did we have in the second group? 6. How many degrees of freedom? 5. So if you add the 5 and 5, degrees of freedom is 10. So that would be a good thing. So we have statistical significance here. Let me stop this